the whole point of this, ladies, is that we want to be able to add and subtract numbers in standard form without having to convert them. Okay? Because when numbers get really big or really small, we kind of want to use standard form. That's why it's there. That's what it's useful for. Okay? So, normally we would do multiply and divide first, but we'll do add and subtract. So if I said to you, we've got to do 3, so I did 3 again. 3.2 times 10 to the power of 5 plus 1.4 times 10 to the power of 3. Okay. So we're just going to add those two numbers. You might see them in brackets. That's to help you identify the difference between an add and the times in between.
Can I have a guess, maybe?
Was there anyone that knows?
Like, no.
If you're going to start with 4.6, then it's incorrect. So if you're not going to start with that, go on, Lena.
Okay, well, I was going to put imaginary ones at the beginning of the brackets, and then expand them, and then collect like terms. What? Can't you just
But if I multiply out by 1, I get exactly what I started with. Yeah. What I will do is congratulate you on trying something you've done before, but it wouldn't help us. So,
did you convert them into like regular numbers?
No, that's exactly what I've said. I don't want to have to convert them into regular numbers. Yeah.
Did you make the 10 to the power like the indices of like it's the same power? So that,
Okay.
and then add them.
That's it. We can't add them at the moment while they've got a different power of 10. Okay? This is why I was talking before about not moving decimal points and moving numbers, because if you move numbers, you'll understand that that 3 does not have the same value as that 1, does it?
What? No.
Right? Because this 3 is to the power of 5. This 1 is only to the power of 3. So they're not like value. They're not in the same columns. That's the thing. If you move decimal points, that whole moving them up the column thing doesn't really make so much sense. Yes?
I'm not sure if you're saying not to do this or to do this, but would it be 4.6
No.
times or okay,
But
you guys wrong, but
no, let's get on and let's see whether what you're doing is right, and you can tell me afterwards. We've got other people. Anna.
So you can't convert them, add them, and change it back.
You can do that. I just don't want you to have to. Yeah?
Could you, okay, bear with me. Could you, you see how it's like a 5 and a 3?
Yeah.
You make so it's to the 3 instead of 5, so you take it out of standard form a little bit.
Yeah.
And then you make it 320 to the power of 3, and then you add them.
Okay.
that's what I was
So yeah. No, it wasn't. Because you started at 4.6. Right. So the thing is, ladies, they're in standard form now. To add them together, one of them's going to have to not be in standard form. Now, you do whichever one you wish. The answer will need to be put back in standard form. So Kiara did this last time. I'm going to apply what she did as well. All right. What we want is to either have them both times 10 to the power of 3 or both times 10 to the power of 5. Which one would you rather use? It doesn't matter.
the bigger one to get it to be smaller.
What?
No, the smaller.
Someone said 3. Let's do it to the power of 3. So that means what we're going to do is we're going to add 1.4 times 10 to the power of 3, but we need the other one to be something times 10 to the power of 3. Okay?
So you have it here.
So what we have to do is, what we can think of it as, well, it's 3.2, and I'm going to split my times 10 to the power of 5 into times 10 twice, and then times 10 3 times. Okay? That gives me the 3 and the 3. Yes.
Can you not cancel the power or something?
So technically, could you, I'm not saying you would do this, 'cause it'll probably take a really long time, but you could put them into like regular
Yes, I've
numbers.
said before, Ali asked that literally a couple of minutes ago. You can put them into regular numbers, but what I'm saying is, the 5 and the 3, yeah. What if they were 18 and 19? No, no calculator. That's the whole point. Okay, we don't want to have to use a calculator. Now, what do we do then? Well, we need the times 10 to the power of 3 bit. Okay, so this is the bit that I want to keep. And then this is the bit that I need to be able to add together.
Do we get time on damage copy or should we what?
What do you need? Do you want to do it now? We'll do it afterwards, shall we? You can copy it down. Right, so what do we do then? What is 3.2? Now, a lot of you are going to go, oh great, finally. Now we can convert 3.2 times 10 to the 2 into an ordinary number. And what would it be? 320. So we've got 320 times 10 to the power of 3 plus 1.4 times 10 to the power of 3.
Wait, what is that?
Now,
Why are they the same color then?
Oh my gosh.
now we've got the same powers, and these numbers are now comparable.
Oh, that's
Okay.
what I meant. Yeah, I meant. Were they?
So what we can do is it's 320 plus 1.4, and it's all times 10 to the power of
6.
3.
I just thought that because there was 2.
I know, but that's where...
They cancel each other out.
No, they don't cancel. This is about the understanding. It is... Imagine these numbers have now been lined up in their columns. Okay? Rather than moving decimal points again. The numbers have now been lined up. I know that both of these numbers, 1.4 and 320, will be shifted along the value system 3 columns. Now, okay? So they match up, so we can now add them together and they become 321.4 times 10 to the power of 3. But our number is not in standard form at the moment. Jen?
A question. If we like had a method like what you did now, and like, because if you did like 120 plus 1.4, like if you had that equation, then wouldn't you have to put brackets? And if like you didn't have brackets in your method, would they mark you wrong?
What brackets?
Because like 320 plus 1.4 times 10 to the power of 3. Like if you solve that by itself, like it wouldn't be the same.
Yes, but what I've written...
would you get it
right,
wrong?
I guess
Would you get it
what
wrong?
you're saying is there would be brackets if I was writing that. I wouldn't be writing that out. This is me just showing you the method.
But if you did
Right?
that in your
No,
method.
if you wrote what we were writing out, okay, I would understand what you've done is converted them both to times 10 to the power of 3, so you've just written this result times 10 to the power of 3. I see what you're saying. That is technically yes. If I was going to do addition before the times by 10 to the power of 3, we ought to have brackets.
So would they like mark you
No.
down if you didn't?
Yeah.
So what's the answer? 2.4 times 10 to the power of 5?
Okay, so now what we need to do is convert it, okay? Lady, did you have a question before we do that?
Yes, I know. It's basic adding, but if you automatically just put it in the 0 because that's what you would do because that's the end of it where the decimal would be. But if it was 3, 2, 1, would that be 2.4?
Yes. Okay, so we need to convert this. It's not in standard form at the moment. That is also a common mistake, is people give this and that's their final answer. Okay? So is there a method that we can actually apply to put it into standard form now? Shall we have a go?
Could you like move the numbers to units like down?
So we need it to be 3.214, and we've got to figure out how many times that's multiplied. Are you studying for different
To
tests?
the power of 6?
to the power of 6. Is there any way, to the power of 6, is there any way of kind of showing our working if we think about what we did up here?
You have 3 there and you move 3.
So what about if we use this method again and we say, well, this is, that bit on its own would be nice and simple, and I would do times 10 to the power of 2, yeah? And I've still got the times 10 to the power of 3 to apply.
What?
Okay, so,
Because 2 times 3 is 6.
alright, so what I've done is the 321.4 is 3.214 times 10 to the power of 2.
Oh, okay. Hey, I got that. Well, I didn't get that, but I got it. I understand.
Okay? So what I've done is kind of the reverse of what I did up here. I've converted the problem bit with the standard form, the 321. I've got to turn that into a decimal. You know that rule, don't you? It has to be between 1 and 10. Okay? So I've converted that into its own little bit of standard form, but I've still got to apply the 10 to the power of 3.
How do you say that spell essentially?
ESSENTIALLY. Okay, and what do we do to finish this off? So it becomes 3.214 times 10 to the power of 5. Okay? Do you want to write that down?
Yes, please.
Okay, recording. So, we're going to do this one. They're not to the same power of 10. So we're going to have to change it. Which one would you like to change? Gabrielle? Which one? The first bit or the second bit? The second bit. Okay, so we're going to have 4.03 times 10 to the power of 18, and we're going to add, well, this will be 1. So what do we need? So we need a 10 to the power of 18. So we're going to have times 10 to the power of 16, and we need a times 10 to the power of 2. So what happens to the 1.3?
It stays 1.3.
It doesn't.
Well, for the time being.
No, it doesn't.
Oh.
Because I need something now that I can multiply by 10 twice to get 1.3. Yeah? No.
Easier to do it the reverse way.
Then, what? Start with the other one?
So yeah, start with
But I asked Gabriella, so she chose to do it this way. It might be easy to do it a different way, but we should be able to do this way as well. Okay, and that gives us something to discuss. One way would have been easier over the other. Which way are you going to choose to do? So what we're looking for, look, if I say the 1.3 needs to be something times 10 to the power of 2.
1,300.
No.
130.
Nope. I need them to have exactly the same value.
0.013.
0.013. Do you all get that? Because, look, the 1.3, I can't change the value of the 1.3. It has to be the same thing. So 1.3 is the same as 0.013 times 10 to the power of 2. Now, this is where we might make the decision and think, well, it would probably have been easier if I'm not happy dealing with decimals like this to have done the other one, the bigger one. But we ought to have these skills, shouldn't we? So then this becomes 0.013 times 10 to the power of, well, now I've got those two together, that will be times 10 to the 18. Okay? So now I've got 4.03 to add to 0.013. So I've got 4.03 add 0.013. Add them together and I get
340.4.
Okay. And we end up with 4.043
Oh, I got that.
times 10 to the power of
2 times
18. Now here's the question.
I love that.
Someone said Gabriella picked the harder one. However, what do you notice about the answer?
They're the same.
Well, not only that, but did we have to do a conversion of the answer like we did previously? No. Whereas before, we did. So does that suggest potentially, if you change the bigger one, you might make the conversion easier, but at the end you're going to have to convert your answer. If you take the smaller one, you're going to have something to do at the start, maybe a bit more, but your answer may well be already in standard form.
I did do it right then.
Okay? Did you get the right answer, yeah?
I just did it when I wrote, before I wrote that full answer, I wrote that times 10, 2 times 10, 16, and then
Not wasting that kind of paper for you to do that stuff. And go back to the other stuff. Okay.
Can you leave it for a second?
Leave it for a second. You writing that on?
If I do it like the way that's like you have to do the conversion, you're okay with that?
I'm okay with whatever you wish to do to get the correct answer.
Okay.
Okay, shall I one more. One more that you can take if you don't get it finished, you can take it with you and get it done. So let's have 1.02 times 10 to the power of 5 minus, no, because you've already done that one, that means you wouldn't have to.
I just want to.
I'll check it afterwards. Minus 2.03 times 10 to the power of 4.
You could have dropped it. Thank you.
Have a go at that. If you don't finish it now, which you probably won't, could you have a go at home for me and bring it in with you?
Wait, try that one.
This one I've just given the subtraction, yeah.